Hello, everyone. Hello after the break. Good afternoon. So we've been hearing a lot about the Polish look at hydrogen economy, finishing with the hydrogen strategy that's being prepared in Poland. Now I'd like to invite you to a bit more look from outside of Poland, so into our international session, and we have three distinguished guests. From three different EU member states, so hopefully they will be able to give you a bit of a better overview of what's going on in Europe. So hopefully we can use those experiences to make sure that Poland doesn't drift away in some strange directions and is in line with what the European approach to hydrogen is. I will start with Ms. Utti Ervasti. She's the Vice President at Neste Innovation, where she's responsible for successful application of hydrogen technologies, focusing on renewable hydrogen mostly and e-fuels production. So two key applications, I would say, looking at the hydrogen economy. So Utti, the floor is yours.
Thank you very much, and good afternoon, Poland. It's a pleasure to be here, here in the grey Finland, so I hope the weather is better there. But anyway, I appreciate that you are very good at organizing very nice seminars. I have had the pleasure of being there myself many times. I really appreciate the discussion culture that you have in Poland and the ability to have nice seminars. As said, I'm representing the Finnish hydrogen cluster, and I'm talking about that right now. But I'm also vice president at Neste, which is a company, which is a leading company in biofuels, and we aim to be the world's leading company in bio and circular solutions. But let's go to the greetings from the Finnish hydrogen cluster. And what is this cluster? And why was it established? So the idea is that last year, a year ago, there was the government invited the Finnish industry associations and the leading companies to discuss whether it would make sense to kind of create a kind of forum for like putting your brains together and figuring out how should we actually take the challenge, the European challenge of introducing hydrogen to a large extent in our industry system and our energy system. And then early 2021, this cluster was established, and now there are over 50 companies who are members, and then 5 industry associations. And the associations represent pulp and paper industry, chemical industry, metal industry, energy industry, and then technology industry. So it covers a huge amount of kind of different players in the field. And how we are organized, we have now a cluster, and we have cluster meetings every month where we look at the recent developments and new kind of funding opportunities. Then as there is the competition law, etc., so we can't start making like the companies then have to form their own kind of projects. So we are not directly financing any kind of projects, only the kind of projects that add to the general knowledge level within the country and within the kind of members, but we are not making any business activities as industry cluster. But then we have formed 4 different working groups, and one is and here the companies, the representatives of the companies participate in them. One is then that how do we differentiate as a small country in this field? So what would be our competitive edges on the market? How can we really make value added and create value networks? Then the other working group was about finding out our investment projects, and could there be perhaps synergies within the projects? How can we develop these projects that we currently have in the country? Then there was one is an international working group, and there we are participate in this EU roundtables, this European Clean Hydrogen roundtables actively. We are also some of us are also have sent some applications to this, or would like to be and participate in this IPCEI projects. There is also some kind of public-private kind of initiative around the Botnia Bay. And then we also share information about the international events. And the fourth working group is that we are dealing with regulation. We follow the regulation now, especially the Fit for 55 package, and we are forming the industry's view into this. So we can comment and make propositions that are then we can be sort of aligning throughout the whole membership things. So they have to be in a way quite general statements. So this is the way how we are working today. In the future, we can work differently. Of course, as the hydrogen industry develops, we are also developing and changing the way how we work. So we will revise this at the end of the year, and then next year we will have also new issues coming up. Then what was something that we created? We created a white paper, a kind of report, how we see the hydrogen economy should be developed in our country. But first, before I go into that and the goals that we have, I will give a brief review about our kind of hydrogen project status. We have now we made a kind of survey among our members, and we identified kind of 17, about 20 hydrogen-related projects, and the total investment cost of these projects is about 1 billion, is more than 1 billion euros. And in our country, these projects are in quite early phase, so we target at this kind of engineering and kind of demonstration phases in the next coming 5 years, and then we aim at kind of larger scale kind of enrollment then later. Now I would like to say that this available funding that is now available from the European Union, that has kind of speeded up this development. So companies are really now sort of speeding up these things. So that's something that sometimes this kind of public funding can also be an accelerator. There, however, we need to make thorough planning, and it always will take its time when it's a question of hydrogen, when it's a question of investments in the industrial settings and industrial plants. So you can't make things happen like very fast. We still find that there is a need for research, further research and development. And we also have noticed that there is a challenge also from within the electrolyzer suppliers, that they have to speed up their ability to produce these electrolyzers to the markets. Also, safety issues are essential. There has been kind of safety expert panels where they say that there will be hydrogen-related accidents in Europe. And we, of course, want to mitigate the risk for these accidents. So we have to, all of us, we have to work on hydrogen safety. Then this total kind of emission cuts that we are now calculating that relate to the project that we currently have is from 4 to 6 million CO2 tons per year. So that's quite a significant thing. It's related to the size of our country, of course. But what is our target now? I'm talking now as the kind of representative of the industry cluster. We see that hydrogen has a very strong impact on leading our country towards carbon neutrality. And Finland had stated a goal to carbon neutrality as 2035. And for us, we are like very enthusiastic about producing this clean hydrogen, as we can see that in our country we have quite a lot of clean electricity available, and there is also a kind of very big plan to increase the share of renewable electricity. So there is a lot of onshore wind mill projects. There is about 800 projects now foreseen, and nowadays renewable electricity is about 10% of our electricity demand, but it's expected to be manifold after that. Then we want to add the kind of systemic value. So we want to have sector integration in the country. We want to be influencing the upcoming European regulation, which we hope will be enabling the hydrogen investments, not being a kind of obstacle to that. We want to increase the hydrogen know-how and solutions, and we also want to be a country that will attract hydrogen-related investments in the future. And we want to make products through which our customers all over the world can also reduce their carbon handprint. So what we want and what we see is important, that we have some kind of public-private collaboration, transparent needed. There can be kind of regional plans or hydrogen hubs, etc., where it's very good to have a dialogue also with the public sector and see how public sector can accelerate this transition. We want to have a clear hydrogen strategy. It's now being also kind of confirmed that we will have our own hydrogen strategy. It will be also part of the energy strategy and climate strategy. But now the government has agreed that indeed is also needed for Finland. And then we need the sector integration strategy to kind of benefit from the hydrogen transition in total. Then we want to attract investments in here, and this is the map of the kind of wind power projects in Finland. And here we are speaking to the government to speed up the permitting process related to this wind power investments. You can also see that there are less projects in eastern, southeastern Finland, and this is partly also to do with our kind of, we have to negotiate with the military about these things. So we always have to. There are some kind of safety issues around the border line. So this is something that we also see that we have to do our utmost, that we really can have like cost competitive renewable electricity to our hydrogen project. So that's a key of all these developments around hydrogen. And then last but not least, we need to create and boost the needed competencies. And we as Hydrogen Cluster have now initiated a kind of study where we are evaluating and assessing the competent needs throughout research and development, throughout education, what kind of hydrogen specialists we need in our industry, in our research and development, so that we can really drive this forward in our country. So all in all, I think that some key takeaways from this my speech are that to develop something new, you need to have collaboration, and it's great to have a cluster where we can look at the opportunities and have a positive mind. We also need public-private partnerships to do this. We need to kind of see how can the subsidies and incentive be used most efficiently to drive this hydrogen economy forward. We also need to look at the safety and also see where we can develop the competence. And in the competence development, I think also there can be a lot of benefits from the pan-European collaboration. So this is what I would like to say, and best regards from Finland and the Finnish hydrogen cluster. Thank you so much.
Yes, thank you very much, Uti. That was a very interesting presentation. I'll quickly look whether there are some questions. I have one for you. Looking at the presentation that you gave, it was very heavy towards renewable hydrogen, which is great to see. But we know that there are some countries in Europe which are a bit more, let's say, cautious or maybe afraid about the costs of renewable hydrogen or availability of renewable energy. Those countries are either pushing or maybe a bit more, let's say, open towards blue hydrogen or hydrogen from natural gas. What would you say is, let's say, Finland's view towards this blue hydrogen, green hydrogen debate?
We are technology neutral. So we also we see and also my company sees that we need also carbon capture and storage. So it means blue hydrogen to kind of have immediate cuts on emissions, while we are developing then the renewable electricity-based green hydrogen. But if we are waiting for everything being 100% green hydrogen, so my question is that can the planet wait? No, we need to have actions on both sides.
Thank you for that. I think that was a very good question, answer to that question, which many people were quite happy to hear. But there is also one other question I would have for you, because you also mentioned that the Fit for 55 package that you at your cluster, the industry is looking at those regulations. You also mentioned that you are working at Neste Innovation, where you focus or deal with e-fuels. And when I look at those two, let's say, issues together, what's in the, let's say, Fit for 55 package, the Renewable Energy Directive, and maybe even the EU taxonomy, just maybe not directly in the Fit for 55, there is this strong feeling that the European Commission is seeing a very limited role for e-fuels, kind of limiting it maybe only to aviation, maybe some use in the maritime sector, but certainly not in road mobility, for example. Would you agree with this kind of narrow view on e-fuels, or would you have to let's say, some arguments against it?
Well, the European Union has its targets to have zero emission vehicles. And if that is like the passenger cars should be electric, so that's how you can interpret the European Union kind of forthcoming plans. And if this is the case, what do we have there then? We have the heavy-duty vehicles, and then we have the sustainable aviation, and being this kind of if this kind of regulation comes into force, e-fuels have to be developed mainly for the aviation segment and also for the maritime. This being said, maritime industry has been quite sort of a low-cost fuel user, so that's in a way a challenging thing, and it will also be challenging for the aviation industry. But this is how we see it at the moment, and we see that the primary kind of outlet for e-fuels in the future will be the aviation, and then it depends on the kind of development of certain kind of e-fuel technologies, whether it will be implied in the large scale in the maritime industry. And we are very interested to follow that development and learn more about it. It depends also what are the choices of the ship owners. What kind of vessels do they want to have in the future? How much are they willing to make new vessels completely?
Thank you. Yeah. Thanks for that answer. I was looking at the time. I think it's very interesting, and I would like to discuss it further, but we need to move to another speaker, I guess. Next is Mr. Matthias Kettler. Matthias is a mechatronics engineer and has more than 13 years experience working for international research and development companies in the automotive sector. Also having worked in technical sales in Europe, Japan, China, and India. In 2020, he joined Wystrach as head of sales, and I guess that's where he's working currently as well. So, Matthias, the floor is yours.
Thank you, Gregos. Thanks for the kind introduction. Thanks also to Marek for organizing this very nice event here. So it's really good to see that there's so much passion and drive here about hydrogen, and there's already quite a good established connection between this region here and our company. Just 2 months ago, we had a visit of some industry representatives from this region in our company in Weeze. So it shows there's a lot of interest in technology, in hydrogen technology, and we are happy to support, to be partner here in Poland with our products and technology. So today my presentation will be about hydrogen refueling technology, which is one key element in this whole transition that we are facing. So we need to have the right technology to refuel and to be prepared for the transition in the mobility. And there are different approaches, different challenges coming with refueling technology, and I would like to point out where are the major challenges and which are the solutions for the individual problems. I will start with a short overview about the company. So our company is located in the western part of Germany, close to the border of the Netherlands. We are around about 200 employees, and yeah, we have more than 30 years experience with handling hydrogen and other pressurized gases, and that's what brings us into the situation that we have products available, reliable products, and that's what we are now benefiting from. Usually at this point, I'm stating that we are a family-owned company. That's what I've stated the last years, but this topic changed now. So just last week, it was announced that company Wystrach will become 100% part of Hexagon Purus. Hexagon Purus is another company deeply involved into hydrogen technology. They are a major leader in production of Type 4 composite cylinders. And there is now a very good fit of cylinder and storage technology with the system know-how of Wystrach. So we think this is a good fit. And after final closure of this whole topic, which is expected in November, Wystrach will be 100% part of Hexagon Purus. So what are our products? Wystrach is involved in hydrogen technology in 4 major areas. So one topic is the storage of hydrogen. Here we offer solutions to store hydrogen in a range of 200 to 1,000 bars for different applications. We are a major supplier for distribution systems, so transporting hydrogen on the road, which is an essential part also to supply refueling stations, which is important to bring hydrogen from the production side to the consumer side. We are developing refueling solutions, so we have plug-and-play solutions for hydrogen refueling for small fleets, but we are also involved in big stationary solutions. So our equipment is part of the biggest refueling station in Europe, which is currently under construction in Frankfurt area. This is the station where next year 27 hydrogen trains will be refueled regularly. So there also we are supplying equipment. And we are involved in tank system development and delivery. And I think one well-known example is the Alstom train, the island train, which was just recently here in Poland as well. And the train on the roof has a hydrogen storage system, and this system is developed and produced by Wystrach. So what are the use cases and requirements for hydrogen refueling? So looking a bit into the future, we will have several groups and use cases. And you can imagine that when we want to roll out the transition, we need to have big fleets of hydrogen vehicles. We need big hubs where big fleets are stationed and where they are getting refueled. But there will be also small fleets in certain areas, certain industries, certain partners. They will start with a small fleet and they need solutions for small fleets. And the third area is where we have kind of isolated fleets. So these are fleets where the vehicles are not able to go to the refueling station, but where the refueling station has to go to the vehicle. And these three use cases will deal with different solutions, finally. So with big fleets, there is a really high demand of high frequent refueling. So over the day, there will be a lot of vehicles coming, getting refueled. There is a high demand of hydrogen, and it's a variable demand. It's unpredictable how many vehicles will come, what will be the consumption of each individual vehicle. So there is quite a challenge to supply constantly and properly the high demand of hydrogen. And this is mostly when we talk about big urban public transportation hubs or train hubs where big fleets of hydrogen trains will be refueled, or logistic hubs where companies with a high transportation demand will have their fleets and they need to get refueled. When we talk about small fleets, it's especially a topic now for the introduction. So I think yesterday in the presentation of Toyota, we could see there are companies now delivering vehicles, there are buses on the market, there are trains coming on the market, there are trucks. Slowly they are coming, they are growing, so many companies will start with small numbers of vehicles and try to get experience with hydrogen, try to get a feeling about the technology. Usually you have quite a good understanding of how much hydrogen is required to refuel these vehicles. You know quite well at what time they will come to the hub, and you can plan the refueling events accordingly. Now here it's more about regional public transport, also about small logistics companies or private companies which start with small fleets of vehicles. When we talk about isolated fleets, we talk about construction machinery, we talk about agricultural machinery, but also about ships and small helicopters or small planes. So these are the machines which usually are not going to standard public refueling stations. There is a very flexible refueling required, so flexibility in terms of changing the location of the refueling station. There's a very individual demand, so you can imagine a ship has a completely different demand than maybe a tractor or a small agricultural machine, so the system needs to be able to supply small and big amounts of hydrogen. So it's not only vehicles which cannot move, but it's also in areas where the access is limited. So what does that mean? What are the requirements in this, for these three types of fleets? Looking to the big fleets, as I mentioned, we need a very fast refueling process. So the vehicles, they don't want to wait very long. They want to be refueled in a few minutes. Therefore, we need standardized refueling protocols, we need cooling equipment, and we need to have a safe and automated process. From HRS technology point of view, we need a very high reliability. So we cannot afford a system which has a very high downtime. So we need the system to be available continuously, 24 hours. The system must be scalable, so it must be possible to adjust the size of the system without changing the whole strategy. And the TCO, so the OPEX costs, need to be in a good manner, as the whole system must finally be affordable. What are the challenges? One challenge that we will have is to ensure a continuous hydrogen supply chain. So there must be a strategy how to make sure that every day there is enough hydrogen available to supply to these vehicles. We have a high power demand, as you know, that hydrogen refueling stations, they work differently to conventional diesel stations. You need power for compressors, you need power for cooling, and there you must find a compromise to make sure that the costs for ensuring the hydrogen being available go down. So the power demand has to go down, and at the same time you must show, if you install such stations at existing hubs, there is usually not much space available, so you need to find solutions which are space saving to to make sure you can still handle the vehicles and the logistics around it. So for small fleets, it's a bit different. So when we talk about small fleets and the refueling process, it's very important that it's easy to handle, because these small fleets are operated by companies who usually have not much experience on handling hydrogen. So they must be able to handle it, it has to work, and they don't want to deeply be involved into the whole process and the strategy. So the refueling process must be as easy as in a conventional refueling station for diesel. Another challenge for small fleet operators going to hydrogen is the topic of getting permissions for operating the hydrogen refueling station. So here we need easy processes. The boundary conditions for getting operating permits have to be clear, and it has to be easy also for small companies to get permits and access to refueling technology. The investment costs must be lower, and it finally has to ensure an easy access to hydrogen technology. The challenges still is that every refueling station needs to have a high safety standard, so also small refueling stations require high safety standards. Also here we have space-saving designs that are relevant and full functionality. So solutions also for small fleets need to have a monitoring concept. They need to have a high availability as well. So it's important to have good functionality for this as well. For the isolated fleets, it's a bit different. Here, the filling of the vehicles, the refueling process can be different, can be flexible, can be vehicle specific. So if you know what vehicle you're going to refuel, you can adapt your refueling process and optimize it for it. The system must be very integrated and mobile to be able to move from one location to another location. And it must be very flexible in terms of operating and operating permit. So you cannot afford that you need an operating permit at each and every location where you want to refuel. And that's different to the solutions for small and big fleets. Here you require permits for the specific locations where you're going to operate these refueling stations. Good. What are the solutions? How could solutions look like? This is our view, our Wystrach view on this, and the focus also for the big fleets is on reducing costs on hydrogen refueling stations. Currently, stations which are set up, they consist out of several elements. There are compressors, there are storages, there is a cooling equipment, and they have to be supplied with trailers coming there. So the whole chain is very big and very expensive. So what are solutions to make it all a bit smaller? And our view, our approach on it is that we avoid to have compression on-site at the refueling station, that we avoid to have storage on-site, that we are using the transport unit, which is anyway there to transport the hydrogen, and this transport unit becomes part of the refueling station. So we are connecting the trailer, which in this case is a 500 bar trailer, so it's the next step of trailer technology. This pressure is high enough to directly refuel buses and trucks. So we require on-site finally only a cooling system, a dispenser unit, and a control unit, and we have a very, very efficient approach for refueling bigger fleets. And the good thing is this is very much scalable, so we can increase the number of trailers. We can use a cascaded approach when we have several trailers there with 500 bar technology, and this allows then also to refuel bigger fleets. So we can increase easily the number of dispensers to refuel more vehicles at the same time. And then there is often the question coming up, what is about hydrogen generation at my refueling station? This is also possible. So it's possible to convert some of these mobile units into stationary units, and then to add at the site where you want to use your hydrogen also electrolyzers and compressor. But it has to be clear that this at the end increases again cost and complexity, at the site, at the refueling station, and you are very much reliable on the functionality of the electrolyzer and the compressor. So whenever you have your own electrolyzers, you need to have the opportunity or the possibility to bring also hydrogen from outside in case there's a problem with electrolyzers or with compressor. You need to have a transport hub to connect your transport units to be able to have a backup solution. And when we are talking about 700 bar, so the 350 bar is the solution for commercial vehicles. When we talk about passenger cars, we have 700 bar technology. The whole system needs to be updated. We need a compressor. We need a 1000 bar compressor. We need a 1000 bar storage. We need another type of cooling. And then the system can be updated also to 700 bar refueling technology. So now there are several options of the flow of hydrogen. So we can go from electrolyzers and compressor storage directly to the dispenser units. But with this setup, there are also other options possible. So in case we have more production of hydrogen than we need for refueling, we can use this setup to move the hydrogen into the carrier and then bring it to another place, to another customer who requires hydrogen. And then the third option is to go from the 500 bar storage. So the compressor needs to be relatively small compared to other stations. So we have already 500 bar available. We need to go to 1000 bar. We need a small storage for 1000 bar. And then we can refuel passenger cars or other vehicles with 700 bar system as well. So what are now the pros and cons? So with this concept, we have a scalable and expandable approach. We can ensure fast refueling and continuous refueling at stations where you work with compressors. The compressor always has to work again and increase the pressure. With this approach, we can continuously, 24 hours, we can refuel the vehicles. We don't need the additional stationary storage, so we are making use, the transport modules are used in a hybrid approach, so they are for transport as well as for stationary operation. And we have a very high availability of the system due to the low complexity. By eliminating compressors and other complex technology, we can make sure that the availability of the system is higher. For sure, transport systems, 500 bar transport systems are more expensive. But the major challenge is that we need to be able to fill these trailers at central hubs to 500 bar. So wherever we are now planning to build production of hydrogen, green hydrogen, we need to make sure that these hubs are able to supply 500 bars into containers so that they can be used to supply the refueling station. That's a big and important topic. What about the small fleets? For the small fleets, we have a fully integrated unit. So it's a unit containing out of two elements, a supply container on the left side and a refueler, which has the full technology of a refueling station, but merged into a container size, including compressor, dispenser, and cooling, and a 500 bar storage. So this is a good solution for fleets of up to 10 or 12 buses or trucks. So exactly a good solution for the start. The unit is mobile and we call it a plug and play solution. You need a power connection and then it's ready to work. Like in this example, the bus comes, the tank is empty, and then we start in the first loop to take hydrogen from the tank container. So we have a cascaded approach, taking first from lower pressure levels, filling up, and only when the pressure is not high enough, we are taking pressure from the 500 bar system so that we are able to fill up the buses or trucks tank up to 350 bar, and then the bus is ready to leave. Advantages of this system is it has a mobile character, it's integrated, also the logistics concept is integrated by using a transport container as a supply module. It's very energy efficient and it's very compact design. For existing hubs where you have not much space, it's a good solution, but it's a solution not for large scale hubs, it's for smaller fleets. It's for up to 10 or 12 buses. Also passenger cars can be refueled, so 700 bar vehicles can be refueled, but they cannot be refueled to the full tank capability. So then looking to small fleets, isolated fleets, here our solution is a so-called tank wagon. It's a transport unit for 500 bar, which has a dispenser inside to control the flow into the vehicles. There is no cooling, there is no compressor. It's a very simplified version. It's a low-cost version, and still it allows to refuel the systems, buses and trucks by bringing hydrogen using the pressure difference from the trailer to the truck, and this allows to refuel 5, 6, 7 trucks and buses with one load, and then the system has to go back to the hub and need to be filled up. We are here using again a cascaded system that allows us to use as much hydrogen as possible from this trailer load, and then again it has to be refueled up to 500 bar. Here we have the full mobility, so the system is extremely flexible, can go from one day to the other to another site, or even different locations on one day. We have no installation time, we have no external power supply, lower investment, and it's selectable size. So you can start with a 20-foot container as a base or with a 40-foot container, so there are several options for it. We have limited capacity. We have lower refueling speed because we have no cooling inside, so we have to be slower with refueling. And again, we need to refuel the trailers at 500 bar level. Good, so summarizing my presentations. So there are different refueling technologies which we are applying, and they are depending on the different application and fleet sizes. So there will be several small fleets coming up now. So we need solutions which are low in investment to deal with the small fleets. But a major topic is to combine the transport, to make transport more efficient, and at the same time bringing transport and refueling technology together. So the trailer will become part of the refueling station. This saves money and energy and makes transport on the road more efficient. So transporting at 500 bar is more efficient than transporting at 200 bar. And by putting a lower complexity on the refueling station side, we reduce downtime and we reduce maintenance costs as well. And what we need for this is we need to be able to transport large amounts of hydrogen. Even it's still a bit far away because we have this small number of vehicles. It will change, so we will have bigger sizes of fleets, so we will need to transport more hydrogen, and therefore we need to be able to compress and transport at minimum at 500 bar and supply the stations with this high pressure. Then thank you very much for your attention, and I'm available for any questions. Thank you.
Thank you, Matthias. It was a very comprehensive presentation. I have a couple of questions, to be honest with you, but conscious of time, I think we need to switch to our next speaker. And if I can ask you to hang around, let's see how we manage with the time, and maybe we'll manage to ask you some questions as well.
Okay.
Yes, but now let's switch to our last speaker, which is Guillermo Figuruello. I hope I've pronounced that correctly. Guillermo is an industrial engineer and is working as a business development manager in the Aragon Hydrogen Foundation. And indeed, he's one of the founding fathers of that foundation, having helped to set it up back in June 2015. He was involved in several FCGU projects and also a researcher at Hydrogen for Research, led by the government of Aragon. So plenty of experience. Guillermo, the floor is yours.
Thank you very much, Gregor, for the kind introduction, and obviously for the organizers to invite us, Aragon Hydrogen Foundation, for the second time in a row to the Polish Conference on Hydrogen Technologies. Indeed, I did the presentation on the PCHET project, the first Hydrogen Valley funded project in the European Union in 2019 in Pila. and last year in the previous conference on hydrogen technologies in 2020. So this year I wanted to change a little bit our scope, and we are talking about internationalization, sorry, of cluster and cluster companies. This will be my presentation. So very glad to be here. Let's see. Okay. So first of all, for the people that still do not know Aragon Hydrogen Foundation, we are a private non-profit research center that we were created almost 20 years ago to promote the use of hydrogen as an energy vector. We were promoted by the regional government, the industry department. So we have this close link with the industry in our region, but we are a research center, so we have this via based. Our board is composed of 78 members. Let me advance a little bit on my presentation because I wanted to show how we have built our board since the beginning. We started with 30 members, more or less, really regional focus. But right now we are almost 80 and increasing step by step and tackling the whole value chain of the economy, from the public administrations to the energy sector that is well represented here also by international utilities like Iberdrola, Endesa, Siemens, Vestas. We have also entities coming from the real estate and civil work from the automotive and transport sector. Very interesting, our links with the chemical industry and the metal mechanic, and crucial for our vision and mission, our synergies with all the regional research, training and innovation centers at our region. We have also some links with another entities that are not inside of our boards, but are like collaborators, sponsors. And here we used to tackle associations or regions. For example, we have Chempark, that is a chemical hub in the south of France, really close to our locations on the north of Spain. We have also strong links with the Association of Hydrogen in Chile, which have similarities to the Spanish case that we will tackle later. And we have also a very strong collaboration with the Scottish Fuel Cells and Hydrogen, with the Scottish Hydrogen and Fuel Cell Association. Coming back to my presentation, just a few words about how do we manage our work. We are divided in 3 working areas: R&D department, innovation and consultancy and training. We tackle the whole value chain in hydrogen technologies in our day-by-day work that is based on projects, and some of them, or most of them, that you can see on the image, are funded by the European Commission, especially by the Fuel Cells and Hydrogen Joint Undertaking. We have been developing 3 projects under H2020 program and more than 20 by the PCHET in the last 14 years. So that's quite a good figure for the amount of people, the amount of staff that we have, because we are kind of a small, 25 people working at our facilities. That I would like also to show our facilities that are like a unique installation in Europe to work with large hydrogen equipment, because we have safety measures, gas detection and ventilation equipment, and the most important, we have the facilities linked to almost 1 megawatt of renewable energies, in between wind and solar photovoltaic, both on grid and off grid. We have also 2 alkaline electrolyzers, 1 PEM electrolyzer, and we are about to install an anion exchange membrane electrolyzer commercially, commercial equipment. We can also store hydrogen up to 23 kilograms at 350 bars, and we use this hydrogen in our hydrogen refueling station, because we are also running in the framework of a European project, Transfrontier project with the south of France. We are also running a Hyundai Nexo, a fuel cell and hydrogen electric vehicle. And finally, we are about to start the operation of a testing platform in terms of blending hydrogen into the natural gas grid up to 80 bars in the framework of a European project that started in 2020. So the results will come later. And regarding our strategy agenda, and really linked to the how do we organize our internationalization, we would like to focus on two main points. The Get Higher initiative that has just been launched in by answering the European hydrogen strategy and the green hydrogen agenda that Spain shows up last year. So this is a regional agenda that the Aragon Hydrogen Foundation is promoting among all their both members. This initiative will pave an energy and technology way on hydrogen, is based in almost 80 projects, and will mobilize more than 2,000 million euros during the next 15 years, promoting a hydrogen valley based on hydrogen economy. This is also well aligned to our fourth edition of the master plan in Aragon, and from Aragon 2021-2025. And well, the strategy agenda that we are defining really working day by day and with strong links with the regional industry government of Aragon, I think is really interesting, and we will see the results in the coming years, also with the experience that we have acquired in the last 20 years. For creating this network and the position that we currently have in Spain and in Europe, you must be linked with the strong associations that are taking the voice or are putting the voice in Europe. So the most important, obviously, is, and I'm sure that Gregors will align with me, Hydrogen Europe, both entities, the industry side and the research side. Obviously, we are represented in the research side, in which we are both members since almost its creation more than 10 years ago. And currently, I'm hosting the Hydrogen Valley's cross-technical committee leader. And together with this strong position and work almost day by day in Hydrogen Europe research, we are also giving a technical support to our regional government into smart specialization platforms that they are leading. One of them is the safe and sustainable mobility, and the other one is the hydrogen valleys. Hydrogen valleys are of paramount importance for us and have created a great impact in our business. You will see later in further slides. And well, I think that's all for this slide, because we are also running out of time. I would like to show how this hydrogen valleys concept that I explained before gives internationalization to your entity or to your cluster. We started almost 8 years ago in the Orkney Islands in Scotland, talking with the Scottish Hydrogen and Fuel Cell Association. They have a huge problem on this singular geographic area. They have a surplus of renewable energy, and they wanted to change it. They wanted to profit from the renewable energy that they were producing and make money, business, and obviously decarbonize their industry and their economy. So we found a solution altogether, creating the pioneer and the first experience in terms of hydrogen valleys in Europe. This is the PCHET project with almost 12 million of budget, in which we are producing hydrogen via wind and tidal power, renewable power, obviously, and this green hydrogen is stored and distributed from the production points to the consumption ones. You can see on the image several demonstrators that have been running during the last 2 years. We have several boilers and micro cogeneration experiences. We are also giving grid auxiliary service to the ships that are located in the Kirkwall Harbor. And we have also a fleet of 5 electric Renault Kangoos with a rich fuel cell extended. Next, we participated, or we are participating in the Haven project, which is the second Hydrogen Valley's project funded by the European Commission. This is taking place in North Holland, and here we have a secondary role because I think I have not mentioned in the PCHET we were the coordinators and we were carrying out several technical issues. Here in the Haven, we are on a secondary screen, and we are just developing the studies, the impact studies, and the replication issues, which are of paramount importance for us. And we are doing a similar, similar tasks in the Green Iceland, the third Hydrogen Valley that is taking place nowadays in Europe. This is taking place in Mallorca, and the topic was related to create a hydrogen economy in an island. Here we are also developing an in-depth replication study of Green Iceland, and really located in Iceland, and also developing the roadmap for the Balearic region. This is also really important. We have created in the PCHET project the Hydrogen Territories platform, which is a tool for all the regions that are interested in creating or decarbonizing their economy. And we have strong links here with several entities, and that is giving internationalization to us, but also to our cluster members. And I would like to show you the best success story of an entity in our cluster board, because Calvera, which is an experienced company in Europe working in gas, in pressure gas, is now developing and commercializing internationally their products that have been demonstrated and validated in the PCHET project in 2018. So nowadays they are compressing and distributing the hydrogen in their own trailers. They have also expanded their business cases to the building and commissioning of hydrogen refilling stations, and they are currently, we can say, the only manufacturer of hydrogen refilling stations in Spain in the reference in the Southern Europe. So this is a great business case that we can show you of our cluster. And finally, I would like to show you how also our cluster goes international by different projects out of the fuel cells and hydrogen joint undertaking. We have just been granted by the program COSME, which is quite new for us, in the project called H2 Global, the European Green Hydrogen Cluster Alliance for Internationalization. Here we can say that we are working with you, with the organizers, with the cluster of Pomeranian and several entities working with you in Poland. And we are very glad to finally collaborate with the Polish partners. The project, I think, will start next week. So the kickoff meeting is next week. So please pay attention to your communication into your mailbox, because you will be invited to assist to the kickoff meeting of the H2 Global project. With that, I think I have finished. Many thanks for your attention, and eager to come back to the next or to the next year, to the next Polish conference on hydrogen technologies. Thank you very much.
Yes, thank you very much, Guillermo, and thank you for the time discipline. Unfortunately, as we have only 1 minute left, I won't be able to ask you any questions.
Mamy tylko minutę.
But for the audience as well, if you have any questions to any of the three presenters, please write them in chat, and we'll make sure to forward it for them and see if there is possibility to answer them in writing somehow. So. Thank you very much to all the speakers today, and yes, back to you. Thank you.